So let us begin by discussing some basics. So these basics will be useful for both number theory and algebra. You might have already studied some of the things, but still let us do it again. So let us just list out some identities. A plus b whole square, it is a square plus 2ab plus b square. A minus b whole square, it is a square minus 2ab plus b square. So then by adding these two identities, you get another identity, that is a plus b whole square plus a minus b whole square, which is 2 of a square plus b square. And by subtracting these two, you get a plus b whole square minus a minus b whole square as 4ab. So all these are pretty useful, you need to remember. So this last one is also very useful. So if you know a plus b and if you know ab, and if you want to find out a minus b, then this identity is very useful. Next, a square minus b square is equals to a plus b into a minus b. Next, you should also know the formula for a plus b plus c whole square, which is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Okay, so it is plus 2ab plus 2bc plus 2ca. Suppose if you have a plus b minus c whole square, then it would be a square plus b square plus c square. Now it is plus 2ab minus 2bc, because plus b into minus c is minus bc, and minus 2ca. So plus 2ab minus 2bc minus 2ca. Suppose you have a minus b minus c whole square, it will be a square plus b square plus c square and minus 2ab, and minus b into minus c is plus bc, so it is plus 2bc and minus 2ca. So minus 2ab plus 2bc and minus 2ca. So you need to remember all these identities. So let us just take a quick example how this is useful. Say you want to find out the square of 999. Okay, so you can simply do it by using 1000 minus 1 whole square, and this is 10 power 6 plus 1 minus 2 into 1000. So you'll get the answer quickly. For example, you want to find out the value of 1001 into 999. Okay, so then you can observe that this is nothing but 1000 plus 1 into 1000 minus 1, right? So then this is nothing but 1000 square minus 1. So then you can easily get the answer, right? So this number 1 less than 10 lakhs. So it is 9,99,999. Fine. So you want to find 1001 square minus 999 square. So it is simply 2 into 1000. I have written a minus b times a plus b. Sorry, a plus b is 2000. So it would be 4000. So you need not square 1001, square 999 and then subtract it. If you remember all these identities, your job is much easy, right? And say, let us take one more example. Say you want to find out the value of 3 plus 1, 3 square plus 1, 3 power 4 plus 1, and 3 power 8 plus 1, 3 power 16 plus 1, 3 power 32 plus 1. So this is what you need to compute, right? So just think about the problem. So pause the video and try the problem. Yes, let us begin. So what we do is we just multiply and divide by 3 minus 1. Okay, if I multiply and divide by 3 minus 1, then rest of the terms are as it is, right? So what happens is this becomes 3 square minus 1. Okay, 3 minus 1 into 3 plus 1 is 3 square minus 1, and then 3 square minus 1 into 3 square plus 1, it will be 3 power 4 minus 1, and 3 power 4 minus 1 into 3 power 4 plus 1 will be 3 power 8 minus 1, and then we'll get 3 power 16 minus 1, and then 3 power 32 minus 1, and finally 3 power 64 minus 1. So this is nothing but 3 power 64 minus 1 by 2. Okay. So I mean, you can see how useful is this identity a plus b into a minus b. Okay. Now let us see some more identities. You should also be knowing the formula of a plus b whole cube, which is a cube plus b cube plus 3a square b plus 3ab square. And also another way of expressing it is taking 3ab common in the last two terms and writing it as a plus b. So you should know both the ways of expressing it. A minus b whole cube is a cube minus b cube minus 3a square b plus 3ab square. And this is a cube minus b cube minus 3ab into a minus b. This is the formula for a minus b whole cube, right? So let us say if I ask a cube plus b cube, then this is a plus b into a square minus ab plus b square. And this can also be written as, if you use this expression, a cube plus b cube is nothing but a plus b whole cube minus 3ab into a plus b. So it is a plus b whole cube minus 3ab into a plus b. Similarly, a cube minus b cube, you can write it as a minus b into a square plus ab plus b square, which is also written as a minus b whole cube plus 3ab into a minus b, right? By using this expression, a cube minus b cube can also be written in this way. So you need to remember all these, all these expressions. So by seeing the problem, you need to spot which expression will work for that problem, right? So let us see one more factorization. If there is a cube plus b cube plus c cube minus 3abc, okay, then you can write this thing as a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. Okay, so this is a very important type of factorization. You must remember this. You can verify it by multiplying. You multiplying these two terms, you should get a cube plus b cube plus c cube minus 3abc. Fine. And then if a plus b plus c is 0, then this entire thing is 0, right? So then you can say that a cube plus b cube plus c cube is equal to 3abc. So then a cube plus b cube plus c cube is equals to 3abc. So this thing is also helping us a lot of times. So you need to remember, if a plus b plus c is 0, then a cube plus b cube plus c cube is 3abc. And next thing is, if you have a square plus b square plus c square minus ab minus bc minus ca, okay, then what we can do with this is, that is this expression itself, what we can do with this is, we can just multiply and divide by 2. So if I divide by 2, I'll get 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca. So then this I'm writing it as a square plus b square minus 2ab plus b square plus c square minus 2bc plus c square plus a square minus 2ca. So you keep writing your notes along with me only. Okay. So I agree that the speed is a little bit high, but you try to cope up and write the notes along with me. And whenever I give a problem, you just pause the video and try to solve it. And if you are unable to solve, come back to see the solution. Okay. So this is how the process goes. So this you can write it as a minus b whole square plus b minus c whole square plus c minus a whole square. Okay. So now you can see that this is a perfect square, this is a perfect square, this is a perfect square. We know that perfect square is always greater than or equal to 0, right? Because it can't be negative. Square of something can't be negative if it is real. So this is greater than or equal to 0, this is greater than or equal to 0, and this is greater than or equal to 0. So this is always greater than or equal to 0, right? So if I mention that a square plus b square plus c square minus ab minus bc minus ca is equals to 0. So this implies that a minus b whole square plus b minus c whole square plus c minus a whole square is equals to 0, right? Because this thing we can write it in this way, and then we get a minus b whole square plus b minus c whole square plus c minus a whole square as 0. So now, since the sum of perfect squares is 0, right? Since the sum of perfect squares is 0 and each term is greater than or equal to 0, so this is only possible when each term is individually equal to 0. Okay. So this is called sum of squares. If sum of squares is 0, then each term is 0. If sum of squares is 0, then each term is 0. Right? So this means that a minus b is 0, b minus c is 0, and c minus a is 0. So simply you will get a is equals to b is equals to c. Okay. So if you notice this expression a cube plus b cube plus c cube minus 3abc, right? Then you can see this as a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca, right? This we have already discussed. Now if a cube plus b cube plus c cube is equals to 3abc, okay, then two cases are possible. Then a plus b plus c is equals to 0. This might be true, or a might be equal to b might be equal to c. Okay. So either a plus b plus c should be 0 or this should be 0. And if this is 0, it means that a should be equal to b should be equal to c, right? So a square plus b square plus c square minus ab minus bc minus ca is 0 if and only if a is equals to b is equals to c. Okay. So if a cube plus b cube plus c cube is 3abc, then either this is 0 or a equal to b equal to c. And if a plus b plus c equal to 0, then a cube plus b cube plus c cube is definitely 3abc, right? So let us do one example. Say it is given that x plus 1 by x is equals to 3. So find x square plus 1 by x square, x cube plus 1 by x cube, and x power 4 plus 1 by x power 4. Okay. So you need to find all this. So you can pause the video and try it. And I think you have already done it in your elementary classes. So after trying, then you can see the solution. Yes, so let us begin. So x plus 1 by x is equals to 3, right? So let us just square it. So I will get x plus 1 by x whole square is equals to 9. So a plus b whole square is a square plus b square plus 2ab, which is 9. So this gets cancelled. So I can say that x square plus 1 by x square is 9 minus 2, which is 7. Okay. And now to get x power 4 plus 1 by x power 4, I can square this term again. So x power 4 plus 1 by x power 4 plus 2ab. 2ab is nothing but 2. This is 7 square, right? So x power 4 plus 1 by x power 4 is 7 square minus 2, which is 47. Fine. Yes. So now how to get x cube plus 1 by x cube? It is simple. You just cube the first expression. So x plus 1 by x whole cube is 3 cube. So then a plus b whole cube is a cube plus b cube plus 3ab into a plus b. It is 27. So x cube plus 1 by x cube plus 3 into, now x plus 1 by x you write it as 3, right? Because x plus 1 by x is equals to 3. So you can write this as 3 is equals to 27. So then the value of x cube plus 1 by x cube is nothing but 27 minus 9, which is 18. Okay. Yes. I hope this is clear. Yes. So now let us discuss one more important thing, that square root of a real number is always non-negative. Square root of a real number is always non-negative. So it is a very important but very basic concept. So sometimes you just ignore it, and for example, say you have root 4, you write it as plus minus 2. So this is wrong. Okay. Root 4 is equals to 2 only, because the square root of a real number is always non-negative. Square root of real number 4 can't be negative 2. It can be only positive or 0. Okay, so square root of 4 is only equal to 2. It is not minus 2. Fine. For example, if x square is 4, if x square is given as 4, then you can write x as plus minus 2, because the value of x is equals to 2 satisfies the equation, that is 2 square is 4, and minus 2 whole square is also 4. So both plus 2 and minus 2 satisfies this equation. So hence both the values plus and minus 2 are the solutions of this equation. But when it is given root 4, the answer is only plus 2, not minus 2. So the actual way of doing this is, if x square is 4, then you can write x is plus minus root 2, sorry, x is plus minus root 4, and then you get x as plus minus 2. So after this step, if you write x as root 4, and in the next step, if you write x as plus minus 2, so this method is wrong, because you have written root 4 as plus minus 2, which is absolutely incorrect. The value of root 4 is just 2. Okay. But if x square is 4, you can write x as plus minus root 4, because plus root 4 whole square is also 4, and minus root 4 whole square is also 4. Fine. So square root of 4 is just 2. But if x square is given as 4, then x can be plus or minus 2. Okay. The square root of a real number is always non-negative. Suppose you have square root of say x minus 3 whole square. Okay. So now you just don't cancel square and square root and you write it as x minus 3. Okay. Because say if you have say 4, then I can write it as 1 minus 3 whole square, right? Because 4 is 2 square, and I can write it as 1 minus 3 whole square. Then if I cancel square and square root, I will get 1 minus 3, and the answer is minus 2. But we already know that root 4 is not equal to minus 2. Okay, so this method itself is wrong. Okay, so this method is also wrong. So whenever there is square root of x square, you don't write it as x. Square root of x square, you write it as mod x. Mod means what? Absolute value. Okay, absolute value of x. So absolute value means we just ignore the sign and we just take the magnitude. For example, mod of minus 4 is just 4. Mod of minus 3 is 3. Mod of 3.2 is 3.2. Okay. Mod of 7 is just 7. So suppose you have mod root of minus 2 whole square, then you just don't cancel square and square root, but you write it as mod of minus 2, which is again 2. Okay. So square root of x square is mod x. This is very important. So this was just a little bit of basic thing which we need to discuss. That square root of a real number is always non-negative. Fine. Yes. Now let us do one more example. Say you are given that alpha plus beta is equals to 1 and alpha beta is equals to minus 1. Fine. You want to find the value of alpha power 16 minus beta power 16 by alpha minus beta. Okay. Find alpha power 16 minus beta power 16 by alpha minus beta. Yes, so you can try this by pausing the video and then come back to seeing the solution. So let us begin. So alpha power 16 minus beta power 16, I can write it as alpha power 8 minus beta power 8 into alpha power 8 plus beta power 8, right? Using the formula of a square minus b square is equals to a minus b into a plus b. Now alpha power 8 minus beta power 8 can be further written as alpha power 4 minus beta power 4 into alpha power 4 plus beta power 4. Okay, so this I am writing alpha power 16 minus beta power 16. Okay, so now alpha power 4 minus beta power 4 can be further written as alpha square minus beta square into alpha square plus beta square, right? So this is the expression. And alpha square minus beta square can be further written as alpha minus beta into alpha plus beta. And this is alpha square plus beta square, alpha power 4 plus beta power 4, and alpha power 8 plus beta power 8. Fine. So now you need to find alpha power 16 minus beta power 16 by alpha minus beta. So this is nothing but equal to alpha plus beta into alpha square plus beta square into alpha power 4 plus beta power 4 into alpha power 8 plus beta power 8, right? So this is the value. So now you need to find each of these terms. That is, alpha plus beta is already given as 1. Okay, alpha square plus beta square, all these terms you need to find. So let us find out one by one. So alpha plus beta is 1 and alpha beta is minus 1, right? Yes. So let us square this. On squaring, we'll get alpha square plus beta square plus 2 alpha beta is 1. So we'll get alpha square plus beta square is 1 minus 2 alpha beta. So that is 1 minus 2 into minus 1, which is 3. Okay. Fine. So alpha square plus beta square we already got as 3. Now let us square it again. Okay. Or alpha power 4 plus beta power 4, you can write it as alpha square plus beta square whole square minus 2 alpha square beta square. Right. So a square plus b square, you can write it as a plus b whole square minus 2ab. So this also, I mean, you need to express. You know the formula of a plus b whole square as a square plus b square plus 2ab. But still a square plus b square, you should be able to express it in this way, that a plus b whole square minus 2ab. So this will be useful sometimes in the problems. So alpha power 4 plus beta power 4, we wrote it as alpha square whole square plus beta square whole square. So then this is a square plus b square, which is a plus b whole square minus 2ab. So alpha square plus beta square is 3. So it is 3 square minus 2 into alpha beta is minus 1 whole square. So this is 9 minus 2, which is 7. Okay. Now similarly, alpha power 8 plus beta power 8 is alpha power 4 plus beta power 4 whole square minus 2 times alpha beta whole power 4. So this is 7 square minus 2 into 1, which is 47. So then finally alpha power 16 minus beta power 16 by alpha minus beta, it is alpha plus beta, alpha square beta square, alpha 4 beta 4, and alpha power 8 beta power 8. So alpha plus beta is 1, alpha square plus beta square is 3, alpha 4 beta 4 is 7, and alpha power 8 plus beta power 8 is 47. So I think if you simplify this, you should get 987. Fine. So you just try to copy the solution along with me. Okay, solve the problem along with me itself if you are not able to solve on your own. Okay, fine. So, but if you are not able to write the solution, then pause the video at that point and copy down the solution first. Yes. So let us move to the next example. Say you have a power 4 plus a square plus 1. Okay. So how do you factorize this? A power 4 plus a square plus 1. First of all, can we factorize this? Okay. So this is a very important type of expression which will occur frequently in examples. So see, a power 4, I am writing it as a square whole square plus 1 plus a square. Fine. So now 1 I can write it as 1 square. So it is a square plus b square. So this is a plus b whole square minus 2ab, right? A square plus b square is a plus b whole square minus 2ab. So this is a square plus 1 whole square minus 2a square plus a square. It is minus a square. So now this is a square minus b square type, right? A square minus b square type. So this is a plus b into a minus b. So it is a square plus 1 plus a into a square plus 1 minus a. So you can write it as a square plus a plus 1 into a square minus a plus 1. Fine. So a power 4 plus a square plus 1 can be written in this way. A square plus a plus 1 into a square minus a plus 1. So whenever you see this expression, you should be able to factorize this into these two. Okay. Next, one more very important expression is a power 4 plus 4b power 4. Okay. So it is also similar of this kind itself. So this is a square whole square plus 2b square whole square, right? So I write it as a plus b whole square minus 2ab. Fine, because a square plus b square is a plus b whole square minus 2 into a, which is a square, into b is 2b square. Okay, is this clear? This is our a, it is a square plus b square. So we wrote it as a plus b whole square minus 2 into a, which is a square, into b, which is 2b square. So now this is a square plus 2b square whole square minus 4a square b square, which is 2ab whole square. Okay, so it is still a plus b whole square. Sorry, it is again of the form a square minus b square. So you can factorize this as a minus b into a plus b. A minus b into a plus b. Okay, so this is also very important. Okay, so you not remember the factors, but you remember these expressions. That is, whenever you see a power 4 plus b power 4, or whenever you see a power 4 plus a square plus 1, you should quickly remember that these can be factorized. And the way to factorize, you should remember that you should write it as a square whole square plus b square whole square. Then you can write it as a plus b whole square minus 2ab, and then it will get factorized automatically. And similarly for this one, you can write it as a square whole square plus 1 square, and then you can factorize it, right? So you need to remember these expressions, a power 4 plus a square plus 1 and a power 4 plus 4b power 4. So whenever you see these expressions, you should quickly remember that we can factorize this. So this identity is called the Sophie German identity. Okay, so this is very important. So this thing. Yes. So let us move. Now let us see how to factorize a quadratic. How to factorize a quadratic expression. Okay. Say we have x square minus 5x plus 6. So how do we factorize this? Okay. The technique is you need to break this middle term, that is the coefficient of x, into two terms such that their sum is x, such that their sum is minus 5x, but their product is 6. I mean, you need to break minus 5 as two numbers such that their sum is minus 5 but product is 6. So if you think, then those two numbers are minus 2 and minus 3, right? Minus 2 and minus 3, if you add, you will get minus 5. And if you multiply minus 2 and minus 3, you will get 6. So let us do that. So this is x square minus 2x minus 3x plus 6. So then in the first two terms, you can take x as common. And in the last two terms, you can take 3 as common, right? So then now you can take x minus 2 entirely common in these two expressions, and you'll get x minus 2 into x minus 3. Okay. Suppose you have x square plus 5x minus 6. So you can pause the video and try it. Yes, let us begin. So now you need to split this 5 into two terms, into two numbers whose sum is 5 but product is minus 6. So then I'll split it as plus 6 and minus 1, right? Because 6 minus 1 is 5 and 6 into minus 1 is minus 6. So then I'll take x common, and here I'll take minus common, right? So then I can take x plus 6 common. So it is x plus 6 into x minus 1. Okay. I hope this is clear. Yes, let us move on to the next one. Say you have x square plus 9x minus 52. Okay, you need to factorize this. So how will you do it? So you need to split this 9 into two numbers whose sum is 9 but product is minus 52. Okay, so 52, I can see that 13 fours are 52. So I can split 9 as plus 13 and minus 4, right? So now you can repeat the process. You can write 9x as 13x minus 4x and take common, and you'll get the factors as x plus 13 and x minus 4. Okay. Say we have x square minus 10x plus 16. Okay. So then minus 10, you can split it as minus 8 minus 2. Their sum is minus 10 and product is plus 16. So the factors are x minus 8 and x minus 2. Okay. So let us do one more. Say you have x square plus say 17x plus 30. Okay. So then 17 you can split it as plus 15 and plus 2, right? Because 15 twos are 30 and plus 15 plus 2 is plus 17. So then the factors are x plus 15 and x plus 2. Okay. So this is the way which you can factorize a quadratic. Okay. But remember that all the quadratic expressions are not factorizable. Okay. So we have already, we have only seen the expressions which we can factorize. So the technique is you split the middle quotient, that is the quotient of x, into two numbers whose sum is the quotient of x but whose product is the constant term. Okay. And then you can easily factorize this. Yes. So let us move on. Say you need to factorize this. Factorize x cube plus y cube minus 1 plus 3xy. X cube plus y cube minus 1 plus 3xy. Okay, so you can pause the video and try it. And if you are done, then you can come back to seeing the solution. Yes, so let us begin. So if I see this a cube plus b cube, then I am getting an intuition that I should express it as a cube plus b cube plus c cube minus 3abc. Okay, so then I can write this as x cube plus y cube minus 1. I can write it as minus 1 whole cube, right? And then minus 3 into x into y into minus 1. This is plus 3xy. Okay, this entire thing is nothing but plus 3xy. So then you can clearly see that this is a cube plus b cube plus c cube minus 3 into a into b into c. So then we can write it as a plus b plus c, right, into a square plus b square plus c square minus ab minus bc minus ca. Okay, so then this is x plus y minus 1 into x square plus y square minus xy plus x plus y minus plus 1. Okay, so these are the two factors of the given expression. So you just copy down the solution and then we can move further. Fine. Let us take another question. Say it is given that 9x square plus 4y square plus z square minus 6xy minus 2yz minus 3xz. Okay, this is equal to 0. So you need to find x is to y is to z. So you can pause the video and then try the solution. Fine, so let us solve this. So first of all, you see that there is only one equation, but there are three variables, x, y, and z. So then it is not so easy to solve it unless you have some boundary condition. Boundary condition means sum of squares is 0. Okay, this is a boundary condition. This will be true only when this is 0 and this is 0. So here you will have A equal to B equal to C. Okay, there must be some boundary condition occurring here. So if I see this, then I get the idea of, see, I can write this as 3x whole square plus 2y whole square plus z square minus 6xy is nothing but 3x into 2y, and minus 2yz is nothing but 2y into z, and minus 3xy is nothing but 3x into y. Okay, sorry, there is a slight mistake. So instead of 3xy, you make it as 3xz. Okay, so this is 3xz. So this you can write it as minus 3x into z equals to 0, right? So now if you see this, this is of the form a square plus b square plus c square minus ab minus bc and minus ca, and this is equal to 0. Okay, so we have learned that if a square plus b square plus c square minus ab minus ca minus ac is equals to 0, then simply we can write that a is equals to b is equals to c, right? A square plus b square plus c square minus ab minus bc minus ca is equals to 0. This implies that a is equals to b is equals to c. This we have already learned. So then we can write that 3x is equals to 2y is equals to z. Okay, so x is to y is to z is nothing but, so you assume that this is equal to some constant k. So x is k by 3 is to y is k by 2 is to z is k. Okay, so this is 1 by 3 is to 1 by 2 is to 1. So you can multiply by 6. So you'll get 2 is to 3 is to 6. Okay, so x is to y is to z is 2 is to 3 is to 6. Fine. So this is a very important concept, that a square plus b square plus c square minus ab minus bc minus ca, a cube plus b cube plus c cube minus 3abc. So I mean, these expressions will be written in different forms. You must realize this, that it is written in this way. Okay, and then you should be able to factorize it. Yes, so let us move forward. Now say you need to factorize x power 8 plus x power 4 plus 1. So you can pause the video and try it, and then you can come back to see the solution. Yes, so let us solve this. So I can write this as x power 4 whole square plus x power 4. Okay, just a second. I can write this as x square whole power 4 plus x square whole square plus 1. Why I have written it in this form is because now I am remembering this a power 4 plus a square plus 1, right? We know that this can be easily factorized, and we know how to factorize this also. Okay, so this x square whole power 4 plus x square whole square plus 1, I can write it as x power 4 whole square plus 1 square plus x square whole square, right? So this is a square plus b square, so this is a plus b whole square minus 2ab plus x power 4. So this is x power 4 plus 1 whole square minus x power 4. Okay, so this is nothing but x power 4 plus 1 whole square minus x square. Okay, so then this is a square minus b square. So this is a plus b into a minus b. Okay, so these are the factors of x power 8 plus x power 4 plus 1. So this, I remember this while solving the problem. Okay, whenever I mean, as and when I looked at the question, immediately this came to my mind. So I just use the technique to factorize this one. Okay, that is writing a power 4 plus 1 as a square plus 1 whole square minus 2a square. That's what I have done here. So just copy the solution and let us move to the next question. So you need to factorize x power 4 plus 324. Okay, factorize x power 4 plus 324. Yes, so whenever I see this, now I'm remembering this formula: a power 4 plus 4b power 4, 4b power 4. That is the Sophie German identity which we have discussed. So if I mean, if this is coming to my mind, then I can easily see that this is of the form x power 4 plus 4 into, this is 81. So I can write it as x power 4 plus 4 into 9 square. Okay. So now once this is of the form a power 4 plus 4b power 4, we know that this can be factorized. And the way is, you can write this as x square whole square, and this you can write it as 2 into 9 whole square, right? So then a square plus b square, you can write it as a plus b whole square minus 2ab, right? So this is x square plus 18 whole square minus 4 into 9 into x square. So this is x square plus 18 whole square minus, this is 6x whole square, right? So then this is x square plus 6x plus 18 into x square minus 6x plus 18. Okay. So this is how we can factorize x power 4 plus 322. Okay. I mean, if you don't know this, then if you directly say without this session, if you have looked at this expression, then to factorize this, I mean, it's not so easy. It's not so clearly visible that how you can factorize this. But it is important to remember this idea that a power 4 plus 4b power 4 can be easily factorized. So we have used that idea to factorize this. Okay. So let us do one more question. So you need to factorize 8a power 6 plus 5a cube plus 5a cube plus 1. Yes. So this is also an elegant question. So pause the video and try this. Okay. Try to spot the idea, and if you spot the idea, then it's just one step. So try to think about this. Yes, let us begin. So what I'm doing is, I'm writing this 8a power 6 as 2a square whole cube. Fine. So this is 2a square whole cube plus, this is 1, I am writing it as 1 cube. Okay. Now, I mean, I want to express it in the form of a cube plus b cube plus c cube minus 3abc. Okay. So then there is one more term which is to be added, that will be acting as a cube plus b cube plus that will be acting as c cube. Okay. So minus 3 into, my a is 2a square and b is 1 and c is something. Okay. So now if you observe this 5a cube, okay, this is minus 6a square, right? So this is minus 6a square. If I just multiply a here, then this is minus 6a cube. Okay, minus 6a cube. But we want plus 5a cube, so it's not working. So what I'm doing is, I'm writing minus a here. Okay, so if I write minus a here, then this is plus 6a cube. This is plus 6a cube. And we want 5a cube. So I can write minus a whole cube. Okay. So 6a cube minus a cube is 5a cube. Okay, is this fine? So I have written it as a cube plus b cube plus c cube minus 3abc. Fine. Let us see this one more time. So 8a power 6, I have written it as 2a square whole cube. So let me rewrite it again. So I'm writing the same step again. So this is 2a square whole cube plus 1, I wrote it as 1 cube. Okay. Now my idea is to express it as a cube plus b cube plus c cube minus 3abc. Okay, this is a standard expression which we have learned. So minus 3 into a is 2a square and one of the terms is b, which is 1, and there should be some c. Okay, so these two things we have already matched. So finally this minus this should be 5a cube. Okay, and this is already 6a square minus 6a square. So if I multiply it by minus a, then this will be plus 6a cube. And if I write minus a cube, then plus 6a cube minus a cube will be 5a cube. Okay. So I have written this as minus a and this is minus a whole cube. Now you can see that this is perfectly balanced. This is 6a cube, this is minus a cube. So this is plus 5a cube. So now this is a cube plus b cube plus c cube minus 3abc, right? So it is a plus b plus c into a square plus b square plus c square minus ab minus bc and minus ca. Okay, so a cube plus b cube plus c cube minus 3abc is a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. So that's what I have written. So this is 2a square minus a plus 1 into this is 4a power 4, right? And then I'm writing the cubic term. Cubic term is this one, right? So this is plus 2a cube plus 2a cube, and then square term. Square term is this one minus 2a square, okay, plus a square. So this is plus a plus 1. So this is finally 2a square minus a plus 1 into 4a power 4 plus 2a cube minus a square plus a plus 1. Okay. So, I mean, at the first sight, when you look at the given expression, it is very, I mean, difficult to factorize this. But once you remember certain identities, you need to remember a power 4 plus a square plus 1. That is not working here. A power 4 plus 4b power 4 is not working. So finally, we use a cube plus b cube plus c cube minus 3abc. That proved to be useful. Okay. So just copy the solution and then let us move to the next one. So say you have ab minus a minus b plus 1. Okay, then you can factorize this as a minus 1 into b minus 1. Okay, from the first two terms you can take a as common, you'll get a into b minus 1, and then minus as common, you'll get minus of b minus 1. You can take b minus 1 common and you'll get a minus 1 into b minus 1. Okay. Suppose if you have ab minus ka minus kb, okay, instead of minus a and minus b, suppose you have minus ka and minus kb. Okay, then you can write this as, okay, I'm just trying to write this as a minus k into b minus k, because a minus k into b minus k, I'll get ab, I'll get minus ak, I'll get minus bk. Okay, so all these terms will appear in a minus k into b minus k, but an extra term is plus k square. Okay, so that I'll subtract it. Fine.